Hello, this is Guillem Godoy. I'm gonna show you an example of how to program an Android app using Android Studio. And we're gonna more specifically program something that will let users play the classical sudoku. Okay? Well, just as a reminder, this is how a sudoku looks like. It is an individual game. I mean, we as players play alone, and it is played on a grid, a 9 times 9 grid, like a matrix with sides equals to 9. And at the beginning, some digits are placed in some cells, whereas some other cells are empty. Well, in order to finish the game, we must fill the remaining cells so that no digit is repeated at each row, no digit is repeated at each column, and no digit is repeated at each 3 times 3 subsquare, but only I'm referring only to those who are who appear here marked. I mean, if you imagine division of the whole matrix into 9 3 times 3 submatrices, then each of those submatrices must contain no repetition, no digit repetition. Okay, so all digits must appear once at each row, at each column, and at each of those submatrices. Okay, well, so let's focus on how to program this. I've already created a new project, and as a template I chose the empty activity. Okay, so this is what we have by default. Okay, and we have also an XML file by default, which is set as content view by this function, but I'm gonna ignore it because we are gonna proceed programmatically creating a new layout. Well, for that, I'm gonna create a new private class called cell, because it seems natural to treat all cells in a uniform way. Okay, because we will have to more or less do the same for all them. For example, we'll need since we will have to change the value of some cells from empty to a specific digit, and we want all cells to look more or less the same. For example, a possibility is to use a button per cell. Okay, here we will need to, if you have Windows, you'll have to press Alt Enter. In my case, sorry. In my case, Option Enter, because I'm using a Mac. Okay. Well, the button will deal with the interaction with the user, but we will also need to know what's the current value, because yeah, for example, when the user press the button on one of those cells for which he is allowed to make changes, we will keep changing the digit. Okay, its new click will produce a change of digit. So we will keep a value for each cell. But remember, some digits are given at the beginning and cannot be changed. Okay, so we will need a Boolean value. For example, let's call it fixed. And if fixed is true, it will mean that this value cannot be changed by the user. Okay, this will correspond to those digits which have been given in advance. Okay. Well, okay, let's create the constructor, and we will pass, for example, the starting value. Okay. We will assume that if this initial value is 0, it means that that cell is empty, and otherwise this is one of those initially given values. Okay, and we will also pass context. Okay, let's call it this. Remember, we need to pass a context to the constructor of the button, and yeah, this is this value that we have here in the onCreate function. We will pass it to the cell constructor. Okay. Well, so what do we have to do here? Well, to start by, the value is set to that we received as parameter. If this value is different from 0, it means that fixed must be true. Otherwise, it must be false. And here we need to initialize the button, well, by passing the context we received. Okay. And if we have a fixed value, then we can set text this value. Okay, so we transform to a string the value we received. Okay, and well, so far that's it. We will need to add an onClick event here in order to let the user play by clicking and changing yeah, each of those cells. But okay, let's put this off, and okay, just to make sure that so far everything is working. Well, we'll need to put those cells somewhere. For example, in an array of cells. Let's call it table. Okay, and we need to initialize this table as an array of 9 times 9 cells. Sorry, went away. Okay, sorry. Yeah, and now for each cell, For each cell, we need to create it. And as a parameter, pay attention, we need to pass the initial value. Okay, let's see which one it is. And the current context. Okay, well, look, we need like to give to have a predefined Sudoku at hand. Well, of course, it would be interesting to give the user a new Sudoku each time, but okay, we will postpone maybe to a future video how to, for example, have a list of Sudokus kept somewhere or a disk, for example, and by now we will have a fixed initial Sudoku. For example, you can find any Sudoku example through the internet. I have here one prepared in advance. I'm gonna copy it. Wait a second. Well, we will have a string input, which will keep a definition of a Sudoku. Okay, let's align this more properly. Sorry. Yeah, for some reason it doesn't let me do this more easily. Okay, look at this. We are concatenating all these strings. So input will be just a sequence of 9 times 9. Well, it's actually a string, but it's a space separated list of either digits or the question mark character. Okay, so now we need to deal with this, and well, we could parse this input in many ways, but the possibility is to create an array of strings by calling the split function. In this case, I'm gonna tell it to split it in by spaces. Okay. Yeah. Wait a sec. Okay. So after this instruction, split is a 9 times 9. Okay, it's an array of size 81, 9 times 9, and each position is keeping each of those characters here. Okay, so which is the initial value that we must pass here? Okay, this is well, let's access the okay the string at position. Okay, look. Yes, this will be the string that we want is at position. Look, I times 9 plus j. Okay, not input, but in split, sorry. Okay, this is the index of the element indexed by I and j. Okay, and okay, the specific character that position, okay, the specific character of this string that we want is that at position 0. Okay, as of 0 will be either a digit or the question mark. But remember, what we want to pass to this constructor is an integer, which will be either 0 if we have a question mark here, or the corresponding digit. So we need a transformation from character to digit at this point. Okay, so here if this is sorry, it's not as of 0, is the char add function. If at position 0 we have a question mark, then we want to pass 0, and otherwise, okay, let's make it a little bit okay. Okay, if this character C is a question mark, we want to pass 0, and otherwise we want to pass its transformation to integer. Okay. Well, so so far we have created this table, and which contains all the cells initialized, but we need to put those cells somewhere. And for example, we're going to use table layout. Okay. Yeah, let's call it TL, table layout. We create it here, passing the context. And yeah, for a table layout, we need, for each row, we need to create a table row. Okay, let's create it here. Sorry. Yeah, and for each table row, we need to add as elements all the corresponding buttons here. As views. Okay, this will be the current button of the or the button of the current cell. Okay, and each of those table rows must be added to the table layout as views, as child views. Okay, and finally, an option is to set as content view this table layout. Okay, well, probably we are gonna change this later, because perhaps apart from the table, we will want to add extra information below. But so far, let's see if this is working. Yeah, probably we'll have some issues because maybe the size of the table is going to be too big for the screen, because we have 9 columns in total. But well, let's fix that afterwards. Just let's see if we don't have a mistake here. So we are going to run this. Yeah, it takes a while. Okay, so apparently there's no mistake. But as I told you, it seems that the size of the table, the width of the table is too big. Uh, well, there's a specific way to fix that. For a table layout, we can call a function which is named shrink all columns. Sorry, set. Yeah, I don't remember. Yeah, this requires a parameter here. Yeah, a Boolean. Wait a sec. Okay. Yeah, shrink all columns changes an internal Boolean, which if set to true, then it will shrink columns in order to make sure that they fit in the screen. But we will call another function stretch all columns, which makes sure that if the table was too small, it will be stretched in order to fit exactly the width of the screen. So the combination, or by calling both functions, we make sure that the width will match exactly that of the screen. Okay, so well, let's see if this is working. Okay, it takes a sec, but yeah, finally it seems to me that it works. So so far we have initialized the game, but we have not yet defined the necessary functions in order to let the user play. Okay, so let's do that. Well, with that aim, we have to set an on click listener here. Yeah, a way to do that is this one, to give an on click listener for each button. Okay, and of course, if the button is pressed, then we will have to change the current value. Okay, but only if if this is not fixed. If this has a fixed value, an original given value, then we simply ignore this click. Well, perhaps alternatively, we might have added here, a conditional here, telling that, okay, we'll define the on-click listener only if the value is not fixed. Okay, well, I don't mind. We can do it in this way. Okay, well, so alternatively or otherwise, if the value is not fixed, we can, for example, increase it. Okay, if it reaches a value greater than 9, okay, we come back to 1. Okay, and finally we must set the text of the button to this value, but we must give here a string. So this will be as before, value of value. Okay, so let's see if now we are able to change those values. So we rerun the app. It's taking, okay, takes a while. We must be patient. Okay, here it is. And now if I press on one of those buttons, the value changes. But yeah, we're observing something which is not nice. That is that, okay, they look the same as the initial values, which is not very nice. In order to distinguish them, an option could be to set a color, set a different color when the value is not fixed, for example. We could set a text color, for example, sorry. For example, we can set it to blue. Okay, let's see if this is working. Yeah, now, okay, yeah, it shows up as blue. Maybe it's not the best color, but okay, at least, yeah, I'm able to distinguish clearly those from the fixed ones, right? Okay, now it would be nice, to let the user know if, I mean, once he has completed the sudoku, whether, yeah, the game is over and finished correctly. Okay, so we need a function to check whether this is over and whether it's been completed properly. Okay, so yeah, this checking will have to be conducted once, yeah, after each click. After each click, we should check whether this is over and this is a correct solution. We have the user, as users, we have provided a correct solution. Okay, so yeah, perhaps we can add here a couple of functions. For example, one of them could be a Boolean function called completed, in order to check whether all the cells have been, I mean, all cells have a value different from 0. So this is easy. If a specific cell has a value equal 0, then we return false. Otherwise, we return true, meaning that it's been completed. All cells had values different from 0. Maybe it's completed. One T, sorry. Now, how do we check that all of those values are correct? Okay, we have a function which will determine whether the sudoku is correct. Okay, remember, we need to check for each row whether all the digits it contains are different, and the same must be done for each column, and the same must be done for some specific subsquares with size 3 times 3, right? Okay, since similar things need to be done, we will try to parameterize, to create a new function which will conduct these checkings according to some parameters. For example, stating which is the first row and limit row. I mean, in this extra function, we will pass a square as parameter. For example, now let's call it I1 and J1. The initial coordinate of the square we want to check, and let's call I2 and J2 to the final coordinate of, well, maybe not the final, the limit, okay? I mean, between I1 and before I2, we have the rows we want to check, and between or from J1 and till J2 minus 1, we have the columns we want to check, okay? So in those, in this subsquare, we want to check whether we have no repetition of digit, okay? So we will use, for example, Boolean array called sin, meaning, okay, with 10 positions, meaning or keeping true for a digit, for a specific digit, if that digit has been seen before, okay? Okay, perhaps it's automatically initialized to false, but I'm gonna make that explicit. Sorry. Okay, at the beginning we have not seen any of those digits, but we traverse this subsquare, this submatrix, and at each point, we will check if the current value is not 0. Okay, of course we will call this once this is completed. But imagine that in the future we want to let the user know on the fly when there's an inconsistency. Okay, if that's the case, okay, it will be good to mark a sin. Okay, to check that we don't have a value. Sorry, this should be value. A value. We need to check if the value is different from 0. I'm thinking of that situation where maybe in the future we will want to check whether there's an inconsistency even before the user has finished. Okay. Well, if the value is different from 0 and this value has been seen, okay, in order not to repeat, okay, since these are two verbose, we will read first this value on a variable. So if this value is different from 0 and we have not seen it before, Okay, well, by the way, we're here checking if this is correct. Well, if it is different from 0, okay, yeah, let's put it as an extra conditional here. If it has been seen before, then okay, then we have an inconsistency, so it's not correct. We return false. Okay, I mean, if it's not 0, but we have seen it. Okay, at the beginning we have not seen anything, but if we have already seen some things and this value has already been seen before, then we return false. This is not correct. Okay? And otherwise we mark it as seen. Okay? We set it to true. Okay? Well, if after traversing all this subsquare we have not found any inconsistency, then we can return true, meaning that this subsquare is correct. Well, now, in order to check all the constraints for each row, if this current row is not correct, okay, this row is defined by I0 and I9. 9 would be the limit, okay, of the, okay, from I0 to I9 we are defining this row, passing 9 because we have used here the strict comparison, so we have to pass an upper bound of for the j's. Okay, if this is not correct, we return false. Similarly, for each column, if this column is not correct, so in this case is 0j and 9j, okay, and now we need to check 9 subsquares. Okay, let's do it in this way. If it's not the square, if the following square is not correct, which is square that starting at 3 times I, 3 times j, and okay, we are remember. Okay, yeah, let's come back to the, in order to understand this better, we come back to the previous screen here. Pay attention, the top left square starts at position 0, 0, but the mid top square starts at position 0, 3. Okay, we're jumping three positions and the same vertically. I mean, the left mid square starts at position 3, 0. Okay, so we come back to the code. So that's why we need to jump 3 positions for each submatrix. Okay, and we need to add 3 extra positions in order to jump to the corresponding limits. Okay. Okay, so if this is not correct, we will return false. Otherwise, if we have not found any inconsistency, it means that everything is right. True, it is correct. Okay. Well, So it would be good to call this function, for example, the correct function and the completed function on the fly. Well, so far, let's try to call the correct function whenever we click on one of those, we change one of those values. Okay, so if what we have so far is correct, we will do something, and otherwise we'll do something else. What could we do? Perhaps we could let the user know if there's an inconsistency. Okay, yeah. For example, we can add a text view below the grid, okay, in order to show a message on the fly. So we'll have we're gonna define a text view here, and we're gonna add below the grid, but for that we need to place everything somewhere else. For example, let's declare a linear layout, and yeah, okay, let's start with the text view. And let's add it. Okay, now let's declare the linear layout. And we'll give the linear layout, yeah, by the way, I'm gonna give it a vertical orientation, and we're gonna add the table layout as a view, and also the text view. Sorry, I'm gonna add the text view as a next view, or as a view under the table layout. Now we have both things, and now we have a place to let the user know whether everything is okay so far. So if that's the case, in the text view, we're gonna put a set text. For example, we could put the empty string, because we don't need to tell him anything, right? Set text, empty string, and otherwise, okay, by now let's let him know that there's an inconsistency, okay, or digit, there's a repeated digit. Okay, well, okay, let me check that I initialized everything properly. I think, yeah, we have the initialization of the text view, the linear layout. Okay, but I forgot to set as content view the linear layout. Well, let's see if this is working. Okay, it seems okay, it's a little bit small, but a text is showing up at the bottom, letting me know that there's a repeated digit, and it is that text becomes empty when we put 3 here, which actually, okay, 3 is actually one of the digits that we have. So we must have a mistake. Okay. Okay. With the rest of with 5, this is empty. Okay. Yeah, we have a 3 here. Oh no, sorry. Maybe. Yeah, I think we have some sort of mistake because in the current row we have a 3 already, and also in the current column, but not in the current supersquare. Okay, the 3 doesn't give a repetition remark, and the same happens with the 5. So this is a hint, or this seems to hint that only the current supersquare is being considered in order to notify a mistake. Okay, because only 3 and 5, which are missing in the first supersquare, are producing no mistake, but 3 should produce 1, right? Okay, so we have a mistake. Let's see if we can find out what's going on. Okay, it seems that we are checking here the columns. Okay, it should be correct. Okay, yeah, maybe the issue is that okay, the idea for this parameter here was to give a bound, an upper bound of the square we are checking, so we should give it an I plus 1, and similarly this j should be j plus 1. Okay, I mean the current row, or the current row here starts at I0, but I plus 1 is the upper bound. Okay, well, let's try, let's check it again. Okay, with a 1 we have repeated digit, with a 2 now a 3 is giving this message, 4, a 5. Seems that the 5 is the only one not producing this message. Okay, well, now, yeah, maybe now the video is quite long, and maybe we have a good base here. And I'm gonna leave it here, but I'm gonna propose you, in order to practice, to make some changes on this program in order to make it look better. For example, it would be good that this text here was centered and a little bit bigger. Okay, that would be a good change. But okay, note that we have not used the completed function, and it would be nice to add here more conditionals in order to check if all the sudoku is completed. Then let the user know if, or just tell him, okay, well, this is over, or you have won. Or if there's an inconsistency, then just let him know. Let's keep this message. Okay, but as an extra change, it would be nice that when there's an inconsistency, to mark in red the tool the 2 digits that are being repeated. Okay, for that, maybe you need to adapt uh, adapt this correct function in order to not only remember what digits have been seen, but also where, in what coordinate they have been seen. Okay, so perhaps you will need 2 extra arrays in order to keep track of what is the I coordinate and j coordinate of for the digits which have been seen so far. Okay, and once we detect that the current value has been seen, we will be able to access those previous coordinates and mark them in red, for example. Okay, well, of course, when extra changes have been done here, we should reset to either black or blue as text color all the buttons accordingly, well, depending on whether they are fixed or not. So it means that, yeah, an extra traversal must be done on the table in order to reset everything to the initial colors. Okay, well, so wait a second. Yeah, we're gonna leave it here. Well, so I encourage you to practice making these additional changes I commented you. And well, I hope you liked this video, and I hope it will be useful for you in order to learn how to program with Android Studio. And I also hope you will follow me in a future video about these specific topics. I will try in future videos to present more functionalities by programming, maybe extending this same app or programming an alternative one. Okay. Well, so see you soon.